I should help you.
Yeah, let's do that. Let's meet up right after class, and I'll send a Piazza post about it.
Okay.
Okay.
Thank you so
All right.
much. I'm really sorry about that.
Yeah, that's fine. Misunderstanding. Don't worry about it. Hi, can you hear me online? Hello, can you hear me? Yes. Okay. Good.
Sin cortar el después
What is going on? What's taking so long?
no, yo no sé.
What the heck? What?
Si yo me cambiaba de
For some reason, I can't join Zoom.
¿Sí? ¿A qué?
What is going on with these? Not sure why I can't join Zoom. All right, so Zoom can't be reached. All right, then I'll use this other laptop. Oh. Okay, can you still hear me online? Yeah, okay. All right, I don't know why I was not able to join Zoom on my other laptop. So let's just use this instead. All right, welcome. Sorry about that. Had some technical difficulty. For some reason, I can't join my other laptop. Oh man, it's bright up here. Can you turn on the lights up back there? No, not that. Okay. All right, excellent. So let's see, where are we? Right. So we just last week we were discussing on how is it that we can interact with the database. Right. We talked about how to design it using UML class diagrams as a language, visual language, so that we can all agree on how to represent data structures. We talked about how to create it, convert that model into a concrete relational model, right? Using create statements, obviously with the limitations of what is it that you can represent in the different ways, with the idiosyncrasies of every particular language or stack where you are, right? So UML is very verbose. It allows you to has a great expression, visual language that can express a lot of great ideas that not necessarily can be implemented straight away with SQL. So we need to be able to be mindful of what the limitations are of what can be converted and how to, how to convert certain things, right? Then we spent some time last week about, once we have the database and we have some data in it, how can we retrieve it? And we took a look at select statements and the different parts of how to do projections, how do you do unions, joins, all sorts of operations of retrieving data from a single table, multiple tables, how to join them, primary key, foreign keys, and whatnot, products. So this week we're going to spend some time on how to update the data. So we talked about how to retrieve the data. This week we'll talk about how to update the data, meaning put data in the first place inside a database, how to update data that's already there, or remove data that is we don't want anymore. Okay. We do have a couple of other topics that are still lingering from last week. We're going to finish that. We'll finish up group by, talk about views, and then we'll jump into this week's topics. Okay. We do have a quiz later on this day on let's see, what did we cover last week about retrieving data, right? So the quiz will be on retrieving data, select statements, about genes and primary keys and foreign keys and things like that. Okay. Group by, some of the material that we're going to cover today as well, and what you're working currently on your assignment. All right, so that's on Friday. So meanwhile, yeah. So let's talk about let's talk about a couple of topics that we missed from last week. In particular, let's see. I believe for querying, we talked about SQL queries, unions, order by. We did talk about a little bit about group by, but not quite enough. So let's talk about it a little bit more, and also views. All right. So before we get going, any questions, any concerns about the course?
Could you
All right.
screen share?
Yeah. So screen share. Yes. Thank you. Let me do that. Screen share. Can you see the screen?
Yes.
Okay. All right, so let's talk about group by again. So again, this is part of the general. What topic? Why is this not showing? No, it's not showing on the screen. What? Okay. Did I do anything? Okay. Yeah. So group by is part of the general topic of retrieving data from the database, right? And so group by is just part of a bigger select statement, where the select statement allows you to retrieve and say, which fields you want, right, from which tables, right, and those tables matching some fields in one table matching some fields in some other table, right? Usually primary keys in one table matching primary keys in some other table, right, where we do a join. Otherwise, we get a product. And we don't want a product. Right? We don't want all the combinations. We only want certain combinations that meet the criteria. So group by allows us to retrieve all that data, right? And once we have that data, it allows you to create certain categories, right? We can group them where certain fields might have certain values that are the same, right? And the example that I gave is that perhaps there's a field where you have either a region, right, or you have a state. And then you can group them and create different buckets where you put, all these 10,000 records. You might put a couple thousand in one bucket, another couple thousand in some other bucket, right? Where the values of a particular field are the same. So you group by that field, yes? And wherever the values are the same, that creates a, make sense? So yeah, so let's talk about some of the great things you could do with it and some of the limitations and how to get around those limitations, all right? Let me silence this. Okay. Oh, what the heck? We're having some video issues here. No. Maybe. Oh, what happened to my? Okay. All right. Can you all still see my screen back online?
No, it's not screen shared.
No
We
screen
can-
share. Screen share. Let's try that again. The desktop. Go out now.
Yeah, we can see it. Thank you.
Okay. Yeah. So, right. So I was saying, right. So it takes a field, and where the values are the same, it creates a different bucket, right? It puts records that have the same value into that bucket. And so here's a quick example on it. So we have here 12 records, of which this is the enrollments table, right? And we see that it just lists 3 different sections, right? Section 1, 2, and 3. And some of the folks got A's, other folks got B's, C's, and D's, right? And so if we group by the section, then we would end up with 3 different buckets, right? 3 different groups. If we group by the grade, then we would get bucket A, bucket B, bucket C, and bucket D, right? And so different records would go depending on how you group it by, right? If you group it by section, then you would have 3 buckets, 1, 2, and 3. And so 4 records would go in each of the buckets. Make sense? If I instead group by grade, then I would end up with bucket A that would have 1, 2, 3, 4, 5, 6 records in bucket A, 1, 2, 3, 4 records on bucket B, right? And just one bucket, in bucket C, we have only 1 record. In bucket D, we only have 1 record. Make sense? Right? Depending on what you group by, you have different buckets and how many records end up in each bucket. Make sense? So let's say we group by section ID. And so so what's the syntax first? Let's take a look at the syntax. So the syntax is that you have a regular select statement, okay? You have in the from where you might have a single table, multiple tables, right? If you're doing a join and whatnot, right? Then in the where clause, you have your normal where you identify which are the fields you want to retrieve, right? What is the normal predicate by which you're filtering out the columns that you want and the ones you don't want. With operators, the great, some are bigger than, less than, or equal to, whatever, right? Also, some joins would be here, perhaps, if you have multiple tables. That's where you have in your where clause. But then at the end, you have this group by statement, right? And in the group by statement is where you're going to determine, okay, which columns are you going to group by, right? Either section ID or by the grade. How do you want to group by? Yes, okay. And depending on this group by, the columns that you're grouping by is what determines what you can select. You can't just select anything, right? If you don't have a group by, then yes, you can select any columns you want, right? As long as they are in the original table, all right? But if you group by, then you have a limit on what is that you can put in that select statement, okay? You can only put in the select statement the columns that you grouped by. Say you group by section ID, then yes, the section ID can go in the select statement, right? Or if you group by grade, right? Then yes, the grade can go in there, okay? You can also put in the select statement any columns that you use to aggregate by, right? Anything you did to create a max, a minimum, or an average, or a sum, or a count, any column that you use for aggregation, those two can go in the select statement. Any other columns cannot go in the select statement, all right? So any other fields you might have had here, right, to do your greater than, less than, and, or, whatever, right? You might have 30 fields in here, right? I want the employees with salaries greater than blah, 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 that, were hired after, January 3rd, blah, 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 all those fields. If they're not in the by, and if they're not in the aggregate, right, those fields cannot go in the select statement. Make sense, right? And the reason is this, right? If you come here, say I group by section ID, right? If I group by section ID, I end up with 3 groups, right? One for section 1, one for section 2, and one for section 3. So in the result, right, I end up with the values of the section ID. Yes, right, 1, 2, and 3. So that can go in the select statement. I can say select section ID, blah 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 blah, group by section ID. Then yeah, that field goes into the final result. But what about these values? Student ID, right? Well, section ID, you'll have the values 1, 2s, and 3s in the resulting group by. But what do you do with these values? What do you do with 9, 10, 11, and 12 in the final result? What do you do with them? These are fine because they're all collapsed into a single value and they're all the same. So it makes sense that they collapse, yes, into a single value. But what would you do here? How would you collapse 9, 10, 11, and 12? How would you collate them, right? Would you add them up? It makes no sense to add up the student IDs, right? Would you average them? Would you sum them up? Okay. So there's no way for the student ID, right, to end up in the resulting select statement. Make sense, right? So it would be a syntax error to say, select a section ID, comma, student ID, yada 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 yada, group by section ID. Make sense, right? It would make no sense unless you could say, well, group by section ID, comma, student ID. Then that's okay. Then student ID would could make it sense, right? And we'll see. So that's a hint of why it cannot make it into the final one. But let's look at another example. Here's another table, right? We have Alice, Charlie, and Bob. And I've highlighted them because I'm going to group by customer, right? And we're going to end up with 3 different groups, right? The Alice group, the Charlie group, and the Bob group. Okay. So in the group of Alice, you're going to end up with 3 records, in the Charlie group, you're going to end up with 2 records, and in the Bob group, you're just going to have just one record. Yes. So now you have to decide, well, what are we going to do with all these guys, right? We know that 1,000, 700, and 300 are going to end up in the Alice bucket, and 1,600 and 100 are going to end up in the Charlie bucket, right? And 2,000 is going to end up with the Bob and the Bob bucket. Yes, but I can't just have the order price. I need to, if I wanted to be in the select statement, right? I need to somehow aggregate them, right? I need to collapse them into a single value, right? Just like the 3 Alices, collapse into a single Alice, just like the 2 Charlies collapse into a single Charlie. Right? I need to be able to say, what do I do with the 1,000, 700, and 300? How do I collapse them into a single value? I need to be able to say, well, I can average them. Does it make sense to average the order price? Yeah, it makes sense, right? I could say, well, what is the average order that Alice has made? That's a sensible question. Or I could ask, well, what's the minimum order, right, that Alice has made, or the maximum, or how many? Those are all sensible questions. Yes. Or what's the total amount of orders that she's made, right? So those are aggregate functions that I would make on how to collapse all 3 values into a single one. Make sense, right? Same thing with Charlie, right? So what's the average order from Charlie, or what's the maximum or minimum or whatever? So at the end of the select statement, after a group by, the group by fields are there, and any other aggregates that on the other fields that I haven't grouped by. But anything that I do not aggregate, say for instance, can I aggregate orders? The dates? Can I aggregate? Well, let's see. Would adding up the dates make sense? Probably not, right? Min and max could make sense, right? When is the earliest order, right? When is the latest order, right? So max or min, the order date might make sense, but adding them might make no sense, right? Or averaging them out, averaging dates. Well, I guess you could say, what's the average time for delivery, perhaps? Yes. But yeah, so anything that I do not aggregate and anything that I don't group by, don't make it to the final group, final select statement. Okay. So here's an example. I am grouping by customer. So because I'm grouping by this field, I can put it in the select statement. Yes. And then I'm adding up all the orders from Alice, from Charlie, from Bob. So there's an aggregation on the order price. So yes, so the order price, and an aggregation of the order price can make it into the select statement. But it makes no sense to put the order price itself, because the order price is really, where for Alice it was 3 values, for Charlie it was 2 values, right? What would that mean? Is it an array that you're gonna print out? It makes no sense, right? So any values that you do not aggregate or you group by cannot be in your select statement, right? Within a group by. So other things that to remember is, if you have in your select statement, right, an aggregate function like this, sum, yes, sum says, oh, you're trying to aggregate this field, yes. That means that you want me to somehow treat the data set, right, that you've selected, in the where clause, in the from clause, whatever, right? You want to you want to treat it as a single set that I need to collapse into a single value. Yes. Typically, it would be, if you have the group by, then it's understood that you want to aggregate per bucket. Yes, each bucket is going to be aggregated. Yes. But if you do not say the field that you want to group by, like for instance, group by a customer, then the interpretation is that you're treating the whole table as if it were a single bucket. Okay. So since you're not telling me by which field are you grouping by, the interpretation is that the whole table is one big bucket, right? So in this case, it's going to add up all the orders, Alice's, Charlie's, Bob. They're all going to be added all up together into one single value. Yes. Right. So it would end up something like this. Right there, the addition comes up to be 5,700. You can also group by multiple columns, right? Where you group by, in this case, by customer and order date, right? So it will look, it won't just look at one field and see where it repeats, Alice, 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 right? Instead, it'll look at the combination of the two fields, right? Where Alice and the other column, if it sees it happening again, right? So it's Alice purchased in September 1st, and then she purchased again in Alice, right? And again, September 1st, right? Perhaps one in the morning and later another order in the afternoon. Yes, right? And so whenever it sees those two repeating, it says, oh, that's a bucket, right? Obviously, the more fields you have that you're grouping by, the more buckets you're gonna have, right? And so this one is grouping by customer and order. Now that I'm grouping by customer and order date, now those two fields can make it to the select statement, right? Because those are collapsed into a single bucket, right? And those values survive, and I can put them in the select statement. Okay. So other examples on grouping by and aggregations, right? So I'm grouping by the major ID. So I have 40,000 students, and I have 40 colleges. So on average, I might have 1,000 students per college. Yes. So it'll create 40 buckets, one per college. Yes. And roughly 1,000 students in each bucket. And then I can ask about those 40 buckets. Say, okay, well, what do I want to aggregate? In this case, I want to aggregate the years, right? I want to know what's the minimum and the maximum year in each bucket, right? So I can ask them, then select the major ID, right? And it aggregates, and each one of the aggregates, I'm going to name them minimum graduating year and maximum graduating year, right? But something that I cannot put in here, for instance, are the student IDs. Even though I'm using the student table has, right, the has the student ID, it has the names of the students, right? It has what else does it have? Well, it has the major IDs of, well, yeah, the major ID, but what else does it have? I think that's it, right? Student IDs and names, right? For instance, it would be a syntax error for me to say comma student ID or comma student name, right? Because again, there's 1,000 students in each bucket. What do you want to do with the student name? You want me to pick out a particular student? Do I concatenate the student names? That makes no sense. Do I average out the student names? That makes no sense either, right? I can only put things that I can collapse into a single value, such as the min max of the year and the max of and the major ID. All right, so this I've been saying what can you put in the select statement and what can't you put, right? So these are some limitations of the group by. It's very powerful. You can do a lot of really cool things, but we have to be aware of these limitations, right? Because we might be asking more than we can get, right? And so the reason you can't, so the reason we cannot put things in the select statement, I already gave a kind of like an intuitive solution or answer to that, right? Is basically what happens is that to run these group by commands, right? The group by runs after the where clause, right? So what the select statement does is that first it identifies all the records, right? Using the where clause, right? So it iterates over the entire data set and it evaluates each record against the where clause, right? The predicate that says, yeah, I want this record, right? I want these records. I want these records. No, no, yes, no, yes, no, 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 right? It's filtering out all the records. And out of the 40,000 records, it identifies maybe 1,000 records. Yes. Once it has identified 1,000 records, then we can group, right? I can't run the group by before I have identified the records, right? And also it runs before the select. Right, so I can't group by, so I have to group by before I choose which fields I want. Right, so it happens in that order. First, the where runs, right? The select whatever from and the where, right? That runs, and then the group by, out of 1,000 records, I'm going to collapse it into 10 groups, right? But I can't do that before I identify the fields, because once I identify the records, then I can say, okay, I'm going to group these 10 over here, and these 20 over here, and these 40 over here. But I can't do that before I actually identify which are the records. So because of that order is that the limitation occurs, right? Right, because first I need to compute what the records are, then I need to compute which fields make it into the final select statement, right? So let's consider back the same database that we've been using, the toy database, and see this the results or how this limitation plays out, right? Of what can't we do, right? Because of the limitations of the where clause of group by. So again, let's go back to the same question we did last week, trying to count how many A's per section, right? And what was the maximum number of A's? Remember that we did a couple of queries there, right? So let's take a look at that. So the question is, I want to count the number of A's per section and then give out the maximum number of A's. Yes. All right. So the way we did that is that, okay, well, I'm going to group by the section ID, right? So in this case, I might have 3 different sections. It becomes 3 different buckets, right? And then I want to count the how many actual records are in each bucket. Right? So that gives me out that section 1 got 3 A's, section 2 got 2 A's, and section 3 got 1 A, say. Okay. So that's calculated by the first one, Q83. Okay. Once we have that, we're going to take the entire data set, right? Notice we don't have a group by, right? So we're going to aggregate the entire data set, and we're going to collapse it by an aggregate of maximum number of A's. So that means it's going to run through my grouped results, right? And it's going to just pick out the maximum number of A's there, right? So it comes out that, section 1 had the most A's, so it comes out to 3, okay? Okay, and that's all fine, right? And it would work out something like this, right? We have this is in the enrollment table. We have the 3 sections, section 1, 2, and 3. And then once we do the first group by, it ends up with 3 different buckets where you have we have I meant this is to be section ID, not student ID. Oops. Let me fix that. It's supposed to say section ID. There we go. Yeah, so it comes out to be 3 different buckets, right? Section 1, section 2, section 3, and the values of adding them up, 2, 3, and 1. And then this is then aggregated into a single value, grabbing out the maximum, and it comes out to 3. Everybody good? Right? Okay, so all that is good and all and good, right? But say somebody asked me, oh, by the way, which section was that? Which is the one that got the 3? So one might say, oh, that's easy, right? I can just say, max A, comma, section ID, right? But by the time that you group from here to here, right? By the time you go from here to here, you lose the section ID because it's not in the group by, right? So it would be a syntax error, right? To in this last group, right? To say comma section ID, which would have been nice, right? This would have been that's 3 A's, and then the section is 2, okay? But because of the limitations, we can't. Right? It would be a syntax error. So let's see what it would look like. So for instance, right? So these are the results, right? We have the first one ends up with section 1, 2, and 3 having number of A's 2, 3, and 1, and then here, I notice that we have the max, and we're not grouping by anything. See that? So the only thing here would be the fields that I'm grouping by, but I'm not grouping by anything, so I can't put any of those here. So the only thing that I'm left with is that the only thing that could live here is the aggregation of the number of A's, and that's what we get, 3. So it would be an error, syntax error, for me to say comma section ID, right? Right. The database might come back and say to me, sorry, but in the aggregation, there was no way for me to collapse these 3 values into a single thing, right? You need to tell me how to aggregate it. Is there a max? Is there a minimum? Right? Is there an average? Is there a sum? None of those allows me to pick out, right? Which one those three match with which value of the section. You see that? Right? There's no operation that says, oh, once you find the max, tell me which section was it. Right? There's no operation that allows me to do that. It's gone. Section IDs are gone. Right? But there's a hack that we could do to answer the question. Yes.
I was just gonna like, I was wondering if maybe there'd be a way to like,
Yeah, that's what we're gonna do. Right. So there's a little bit of a hack that we could do is to join these two. Right. If we join this result with this result and say, I have a Q83, I know the maximum now is 3, I can join this table with this one over here where 3 is equal to 3, right? And it tells me, oh, sorry, right, this 3 is equal to that 3, and so I can pick out the section ID because the value is still in this result, right? I can join these two, right? So to do that, I would do something like this, right? And I got the maximum Q right as max. Oh, I'm sorry. This is for showing the errors, right? You can't do this, right? You can't say just Q dot section ID because I don't have a section ID. It's gone, right? In my aggregation, I don't have the group by section ID, so it's gone. I don't have it, so that's illegal. Or one might say, well, what if we use the aggregation not in the select statement? We use it in the where clause, right? And it says, okay, well, I want the section where the maximum number of A's is equal to the number of A's, and that'll give me the section. But the aggregation can't happen until you do the where clause, right? You first have to run the where clause before you do the aggregation. So because of that order, you can't aggregate because you have not first identified which records you're going to aggregate. Right? So this is also a syntax error. You can't do that. Right? So the hack would be to merge those two tables, right? We can merge Q83 and Q84, where one has the maximum number of A's, which is 3, right? Is equal to the number of A's of Q83, which has a section, right? Q83 has a section. So because of Q83 has a section, I can spit out the section, right, from a cross product of the two queries, right? I can do the cross product of each one, right? Join them. Here's the join, and then grab the section, which basically is doing what? This is iterating over these two tables, right? It's comparing the cross product of this record with this record, and this record with this record, and this record with that record, but then filtering and only keeping the one where the number of A's is equal to the max A's. So it's only keeping this one record, right? And I'm picking out the section ID. Make sense? That's what that does, right? It does a cross product. It does a join between these two tables, which is fine, but definitely not ideal, right? Right? We could absolutely do this. You can have an inline view for each one of these, right? And then you can merge them, right? Join them together. So yeah, you could answer that question, right? But a better solution is to actually, it'd be ideal if I could do this, right? It'd be ideal if I could do that. Right? It says, okay, well, aggregate the values of the number of A's, find what the maximum is, right? And as I am iterating over the sections, right, with their number of A's, pick out which section it is, right, that whose number of A's is equal to the maximum, right? So you can't do that with group by, but you can do it with having. Having is an additional syntax that allows you to do aggregates, right, on the where clause, whereas group by does not, right? So having is literally trying to fix that problem, right? Being able to, in the group by, after the where clause, is to have an aggregate function, right, in the where clause, right? After you've identified what the records are, but before you do the select statement. Okay, so this answer questions such as follows, right? So let's go back to orders as before, right? We had you have Boone appears 3 times, Nielsen appears twice, and Jensen appears once, right? And so now, what we could not do in group by, here we can do in the having. Now you can do the aggregates, right? You can do the aggregates, right? Before you get to the select statement, right? And you can say, okay, well, aggregate all the order prices. In this case, the sum, right? And says, greater than 2,000. In this case, it's aggregating, Nielsen, less than 2,000, sorry. So it comes out to be 1,600 plus 100, that's 1,700. So it picks out Nielsen, right, as being the sum of the order price and the customer. Okay. So this does allow you to do that kind of question. So this one, it's aggregating for the ones that are greater than 1,500. So this allows you to have the aggregates on the where clause as opposed to group by does not. Okay, let's talk about views. All right, so notice that we've been talking about these very we've been doing this very informal assignment here, right? Where we have on the right hand side you have a select statement, yes, and we're kind of like saying, oh well, the results of this select statement, we're assigning it to the left hand side. This amorphous kind of variable that presumably is holding the results of a select statement, yes, which we could then presumably reuse that in later queries, right? And we've been doing it very informally, right? But actually, there's a formal way of doing this, right? Of assigning, the results of a select statement to some kind of variable, right? And then reusing that elsewhere. Okay, let's look at how we actually do that. And I noticed that we have Q3 and Q4, Q83, Q84, and then later on, right, we just use Q83 in a different query. See that? Right. So how do we do that in reality? So in SQL, what we have are called views. Views allows us to do just that, right? Take a select statement that calculates some complex query and identifies, out of 40,000 records, identifies these 1,000 records. It allows us to give it a name. Okay, very much like in programming languages, any programming language will give you all sorts of mechanisms for creating abstractions. Right. The most common way of abstraction is data types. Right. When you say integer or strings or characters, right, those are all abstractions because we don't want to think about the zeros and ones that are underneath. Yes. Right. So we created this abstraction of integers, which is a set of either a byte or so many bytes, so many zeros and ones, and we don't want to do bit by bit operations. So instead, we create a this integer level of abstraction. So we can deal with integers, right, but we can't deal with zeros and ones, right? Same thing with characters and strings. Other ways of abstraction in any programming language is, for instance, the function. Function allows you to grab an algorithm that you find it very, very useful, and you instead of copying and pasting this algorithm wherever you need it, right, you can just wrap it inside of a code block and give it a name, yes, and then you can invoke it anytime you want it, right? You can parameterize it, right? You can pass it arguments, and then make it behave different ways. Other ways that we have in programming languages, are classes, right? Inheritance. All these are mechanisms for abstraction, creating multiple layers of abstraction so that we have really simple stuff, like kind of like small Lego blocks that you can then build on more and more complex things. Yes. So views is a mechanism in SQL for creating abstractions. Right. If you have a select statement that is very useful, and it might be a fairly long select statement that have maybe, I don't know, 5, 10, 15 lines of joins and a whole bunch of foreign keys, primary keys, and a whole bunch of big, huge where clauses with group bys and having, and something really, really big. And you find it very useful. Instead of copying and pasting every time you want, you can just give it a name, right? and say, okay, well, now that I have a name, I can treat it like if it were any table, right? Any data source, any data set, right? Even though it's not a real data set, right? Just like a function, underneath obviously it has 10, 20, 30 lines of code, right? You just are replacing it with just name. So let's look at views and how we can use them. So just like we've been doing so far of saying, a variable is equal to some select, yes, right? Well, the formal way of doing it is to use the create view key command in SQL. You can give it a name, to create the view, the name of the view, and then as right the select statement, right? And whatever select statement, this select statement could be a fairly complex query, right? With all sorts of group bys and aggregations and whatnot, yes? But instead of copying and pasting that all over the place, I can now use the name of the view, all right? So yeah. So just let's look at a couple of examples. Here is a brand new view that I've created called current product list, right? It might be a query that I use very often to identify out of the 40,000 products that I have, most of them have been deprecated, they're not selling anymore. And so I always have to filter out the ones that are not occurring anymore, they've been discontinued. So I want to filter out and find the ones that have not been discontinued, yes? And I use this query everywhere, right? When I do forecasting or sales or whatever, right? So my query is right here. It's just simple 3 lines of code, 3 lines of select statement. But I'm tired of copying and pasting this everywhere, right? So I'm going to give it a name, and I call it current product list. Notice that I deliberately put spaces in this, right? And put quotations, and just to remind myself that this is not a real table. Okay, because now that I've given it a name, I can treat it as if it were a table, but it's not a real table, right? Just to remind me that this is a virtual table, not a real table. But I can use it now anywhere where I would use a table. Right? So for instance, I can now have a query that says, select star from, yada, 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 with a whole bunch of where clauses, right? And use that view that I just created as if it were a table. Yes. I just no, that's a very bad syntax. I did it a little bit just to remind me, just in this academic setting, that this is not a real table. But you would never use actual spaces for the name of a view or a table. Yeah, pseudocode. Yeah. And so now that I've given it a name, I can treat it wherever I could put a table. Now I can put a view. Okay. So this is for instance in this from clause. I'm demoing here the fact that I can use that view that I've just created there. The view can be as complex as you want. The view can be written in terms of other select statements, and those select statements can use other views. So views written in terms of views, written in terms of views, right? Just like you have a function that are written in terms of functions, and those functions are written in terms of other functions, right? You can create a hierarchy of functions where you have, especially if you use top-down design, right? Where you have like a main function that then calls 10 more functions, and then each function calls another 10 more functions, so on and so forth. On that, eventually, right? You have to work with primitive data types, right? And work with the actual code, right? Same thing here. You can have select statements that are written in terms of other select statements. Here we're using an inline view, right, where you have the select statement in terms of this inline view, and those inline views could have perhaps views themselves, right? So again, it could be arbitrarily complex. So this one is saying I'm creating another view called products above average price, right? That it's aggregating first. It's identifying what the average price is for a unit, right? And then that average is being used in this where clause to identify the unit price, filter out those products that have a greater unit price bigger than the average, right? And perhaps I find this very useful, so I slap a name on it, right? So that I can then use this view later on. Okay, you can have views in terms of other views, right? Where you might have another view that calculates the product sales for 1997, right? And that might be a fairly complex select statement, right, where the year blah 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 was 1997, right? And that can be used as if it were a table in this from clause, right, that is inside embedded in another select statement, right, that then defines an outer view at the top, right? So again, you can have any number of views, and so most of the questions that a database will ask will be based on many of these smaller views that are combined to answer more and more complex questions from the database. Yeah, so yeah, we've been using the syntax, all throughout the semester, where you have, Q65 equals to some select statement on the right-hand side, right? Now we have a formal way to actually write that, right? We can say create view Q65 as, right, and then the select statement. Right, now we have a formal way of writing that. And then you can use that view anywhere. You could use a table, right? As if it were an actual table, but it's not. You have to remember, this is not a real table, right? Every time you reference the view, it's as if you copy and paste the underlying select statement, right? And you paste it in here, and it runs every single time, right? As opposed to a table. A table is calculated already, right? And it's stored in a file system, right? And the data is there. In here, these select statements have to run every single time, right? They regenerate the output, right? And then it's used in the outer query. Yeah, so it would be the equivalent, by putting this Q65 would be the equivalent of copying and pasting the value of Q65 and replacing it as an inline, right? That's why oftentimes we call this syntax as an inline view, right? And so and to simplify this, sometimes this is very hard to read, right? And so we would say, oh, just like you have, a very complex algorithm, and you might say, well, why don't you, just put this piece and make it into a function, and this other piece make it into a function, and then you replace the number of the names of the functions, and now it's much readable. Same thing here. If you have all these nested, select statements, well, it'd be much easier to read if you replace each one of these with a view, right? Now the query makes sense, right? So same thing, right? Same thing that when you apply software engineering principles to make it simple to read. It's also, we often use views not only to make it more readable and to be able to tackle complexity and break it into smaller pieces, right? That's what humans do. That's what we are. We're abstraction machines, right? We try to, if we want to tackle something big, we break it into smaller pieces and say, well, you work on that and you work on that, and then we'll integrate together, right? But beyond that, views are also useful for implementing what we call external schemas, right? What we mean by external schema is that we went through a lot of trouble applying best practices of normalization, right? We make sure that we meet first, second, third normal form, right? And we broke it up into multiple tables, yes? And now, but it might be, for us software developers and the data analysts, we might feel proud that our database is well normalized, no redundancies, no inconsistencies. But for the user, right, who wants to use your database, they might find it very inconvenient. Right now, the data has been split into all these tables, right? And if I want to ask it anything, I have to join that table with that other table with this other table, right, to collate all the data into to answer a simple question. Right? For them, as a client, as a user of the database, they might have preferred everything in one big table, right, and be able to sift through it themselves, right? And so that's why we might use views to provide an external schema, right, a virtual schema for these folks that might make it easier for them to reuse, right? So for instance, if you're in the dean's office, right, you might want to, every week or every semester, like to be able to run a report and see how everybody's doing in different courses and sections and across the college, right, without having to do all these, join 4 tables and then doing a group by and then join it with some other table. It'd be great if all those details would be hidden from me, right? And I could just use one nice table that has everything for me, one big report that I can run. Yes, and that's where views are great. I can create a view called student info that just collates information from the enrollments table, from the courses, from the student information, from the college, right, department, and then it places everything in one single view, right, for consumption for a particular set of users, right, the dean's office, right. Same thing with student courses. This, as opposed to deciding that there should be an actual table that is denormalized that should have all this information. That should never be your solution, right? The solution should be that you make sure that your database is normalized, right? And if you need a denormalized view, then that's fine. We can create a denormalized view that groups together all the tables, right, for your particular needs. Yes, right? And it could even be part of some application level logic, right, that uses this denormalized view, right, for generating reports and whatnot. But your solution should never start with, oh well, leave it denormalized because it's more convenient for consuming the data. Yes, you first normalize, and then you can denormalize with a view. Okay. So here's an example for the student courses, which is joining 3 different tables, right? It's having and it's navigating between those 3 tables with foreign keys and primary keys, and aggregating information about the students, the courses, the titles, the grades, the professor, right? And all in one single big report that is convenient for the dean's office, right? Updating the view. So all this, so up to this point, I've been saying, views are just like tables. Well, they're not, right? They're virtual tables, right? They don't actually store anything, right? They run, and then they spit out whatever intermediate results that can then be used by bigger queries. Yes, but they're not really tables stored anywhere in the database, right? They are supported by real tables from where we extracted the data. Yes, right? So one common question might be, well, if they can be treated as tables, right, for reading purposes, what about for writing purposes, right? What would it mean, right, if I have a view that says student information, right, and then I say, okay, well, remove a record from the student information view. What would it mean, right? Because the view was generated from collating some the first 2 fields might come from one table, the student table, right? The 3 other fields might come from the enrollment table, right? And then 3 other fields might come from the department table. Yes, right. So what would it mean if you remove that record from the view? Does it mean that cascades to removing the original 3 records from where it came from? Probably not, right? So we would need to determine what would it mean, or if you update, right? If you update a field in a view, right? And what would it mean? So would it mean that you would have to go to the original record where this was read from and update that record? Is that what we mean? Right? What about if that value is an aggregate? Maybe it's an average or a sum or min or max. Yes, right. If it's an aggregate, it might mean that value in that field actually comes from having aggregated 3 or 10 different records in the original table. Yes. So what would it mean for you to update something? That you would go back and update something in the original tables, right? So that is kind of things I would like you to answer, right? So it turns out that you can update views, right? You can update views, and the database can cascade changes to the view back into the original tables. Yes, but only if there is a unique correspondence, right? If you have a field, right, in your view, which corresponds to an exact field from an original record, right, and the database can unambiguously map, right, and say, okay, this field was taken from this field over here from this record, right? If it's unambiguous, if you update the view, it will update the table. Okay, Same thing, if you remove a record from the view, right, it can be unambiguously determine what record does it match from the original table. Then yes, if you delete that record, it will cascade down to deleting the original record from where it came from. Yes. Okay. But sometimes it cannot be sometimes it cannot be unambiguously determined. How did you calculate this record? Because it could have been a collation, right? An aggregate of multiple records, right? That means that modifying one record in the view might mean modifying 10 records, right, in the original table. So that it's not unambiguously mappable, right? So if you can't do that, then the database will stop and says, no, you can't do that, right? Let's look at a couple of examples. Let's say you do a creative view that joins two tables, right? The student and the department, yes? Right, so you end up with this view here, right? Where some of the fields come from the student table and some of the fields come from the department table, yes? Right, so what would it mean for me to delete this record? I want to delete Joe and Art. Should that mean that you're deleting the record Joe from the student table? Or should it mean that you're removing the art department from the department table? Probably not, probably doesn't mean that you're removing the art department, right? But notice that it's not clear what the intent is. Yes, right? So same thing here, right? If or it might mean, right, if you have a many-to-many where you have a map table that says, if you have more than one department, yes, it might mean that you're removing the relationship, that Joe is no longer in the art department. Maybe that's what you meant, yes? So again, the heuristic is not clear, or what you meant for the database to do, right? So for instance, if I remove Sue, does it mean that I am deleting the student department, the student record? Maybe that's what the intention was, right? To remove the student's record. Probably did not mean to remove the department record, right? Or does it mean that if I'm removing, it means that Sue no longer is in the math department, so this should be null, right? That the foreign key that Sue points to, right, means that it now should be null. Maybe she's no longer registered in any department. Maybe that's what you mean, right? So there is no clear, when it's ambiguous, right? There's no clear thing that the database could do, and there's no way for you to tell it exactly what you want, right? Unless you start, unless you use what we're going to be looking at later next week, stored procedures, right? So stored procedures are a programmatic mechanism by which you can use functional programming and detect, right, what's happening to a view or what's happening to a table, right? You can say, hey, if somebody is deleting a record, right, this is what I want to happen, right? If I'm updating a record, this is what I want to happen, right? You can trigger logic to run and then decide what you want actually to happen, right? And that's what we're going to be looking at a little later. All right. All right. Okay. All right. So let's talk about this week's topic. Yeah. So all that we've been discussing was retrieving data, right? Retrieving data from the database using select statements, from where, group by, order, blah blah blah, all the operations that you can for retrieving data. Let's talk about how did the data made it into database in the first place, right? Who put it in there? So first, we'll take a look at the insert into operation, right? So insert, like the name suggests, right, allows you to store data in the database, right? And the syntax is as follows. The simplest syntax is as follows. You say insert into the table, right? And then the values, right? And the values are comma separated. Yes. Oh, they're not. Sorry. Oh, here. Thought I made this automatic. Dang. Okay, here it is. Right. So this is the simplest syntax, right? And what it says is that the table is going to have a whole bunch of fields. Yes, field A, B, C, right? Maybe the primary key, then first name, last name, social security number, blah 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 blah, right? And they were declared in a particular order. First the primary key, right? And then the first name, and then the last name, right? So it's field 1, field 2, field 3, field 4. Yes. So this syntax is it assumes that the interpretation is that value 1 will be for the first field in the order they were declared. Right. So this is the value for the first field. So presumably the primary key, right? If you declared it first, right? And then this would be the second field, third field, and so on and so forth. Okay. So it assumes a particular order of the fields that were in the way they were declared, right? So here's an example where you might have a person table that you have person IDs, last, first, address, and city. So that if you do an insert, right, this means that you're inserting a particular ID, there it is, right? And then Craig, Daniel, 2 Mill Lane, blah blah blah, Drake it. Okay. So it assumes that this is for the PID, this is the last name, this is the first name, this is the address, and so on and so forth for the city. Right. So it assumes that order. Make sense? Yeah. So the order would be that, right, the 1, 2, 3 would go to the B and XYZ, and then the float down here in that order. All right. Now a couple of things. You can omit values. So for instance, you might provide only the values for the first 2, but maybe not the third one. Okay. And that's fine if the field was declared that it was okay to leave it null, right? That it was okay for it to be optional, right? If instead you declare it not null, right, and you leave it out, right, this insert would fail. Okay. Unless you maybe provide a default value, right? If you provide a default value, then you can leave it out, right? It will just take whatever default value you gave it when you declared it. So you have to be careful whether you can or cannot leave out the field that you're going to provide the value for. Okay. So for instance, this one. If this one, if you don't say anything, then it was okay for it to leave it null. Yes. Yeah, we'll see that in a minute. A second. Yep. With this syntax, you can't. Well, you can put a null. You can put a null, but you can't just skip it, right? So float over here, it would get null, right? If you didn't say anything, unless you specifically say not null, right, and would fail. Or you can leave it out if it has a default, then it takes that particular value and you can leave it out, right? Yeah, you can't skip, right? Like for instance, you want to give the values for B and the values for D, but not for C, right? So you can't just say, 1, 2, 3, comma, maybe another comma, don't put any values, right? Instead, it'll assume that this is the value that goes for this form, for the var chart, right? It won't just go to the float. Instead, what you can do is apply just a null, right? You can apply a null, right? So that the value that you don't have a value for, you can just give it a null, right? But that's if the variable allows it, right? So if you've declared it to be not null, you can't do that, right? You can't just put a null for something that you might say not null, right? It would fail. Okay. To fix that, maybe you would put maybe a default so that if you don't provide it, then it takes that value. All right, so that's syntax 1. That's the first syntax, the simplest syntax, right? Which assumes a particular order in the way they were declared. Or the alternative syntax is that you provide the columns that you want to work with. Because I don't want to have to provide the values for all the columns, right? Maybe most of the columns are allow null, right? And maybe I only have 2 out of the 10 fields are declared not null. So I have to provide values for those. Yes. So maybe I only want to work with those 2 without having to provide values for the other 8. Yes. Well, so what I can do here is provide a subset of the columns that I want to work with. I only want to work with column 2, 1, 2, and 3, not 4, 5, and 6. Yes. And I might not want to be stuck with the order in which they were declared. Maybe I want to put them in different order. But this allows you to say, okay, I want to work with column A, B, C, and then provide the values for A, B, and C, right? In any order you want, right? So this would be the value for column 1, value for column 2, and so on and so forth. But I can swap these, right? I can put them in any order I want as long as I am consistent. Yes? Okay. So an example of this, right, is that I can provide, PID, 5, Norton and Edward, and leave out the address in the city if, right, they allow nulls. Right? Those same rules still apply. Okay? Yeah, so 5, Norton and Edward. Now, if right, so the order now only matters not the way they were declared, but in the order that they fall in column order, right? On where and the data types have to match, right? That the data type of this field has to match with the primitive data type they provided here, the strings and numbers and whatnot. Yes. And the same rules apply as null and not null, right? The default values, same rules apply, right? If you don't provide it. So say you only want to work with, you have 4 fields here, B, C, D, and E, right? And you're just working with B and E, right? So meaning that you're not providing values for C and you're not providing values for D, right? Only for the first one and the last one, right? And that's okay, right? If C has a default value, so that's fine. I can just skip it, right? It's not there. It's just going to get a default value of 2, 3, 4. For D, it was also okay, right? I didn't say it was not null, so that's fine. I don't have to provide a value for it. Yes. And E, I'm just saying null, right? I could have just left it out, right? Unless this would have said not null or something, right? Then I would have to provide some kind of value, right? If D would have said that it was not null, then this would fail, right? Because I'm not providing a value for D, right? And it doesn't have a default value, right? So it has a and it's explicit telling me that I need a value, right? So that insert would fail. Or right, I could say not null, but if you don't give me a value, by default it's 3 to 1. So now this would work, right? And I could decide whether to leave out the value or not. All right, another syntax, useful syntax, is the insert into select, right? Where you provide an insert and instead of me providing the values one by one, right, I can copy values that I might have in other tables, yes? Or multiple tables. I might have a whole bunch of tables that I can join, go fetch values from this table, join it with values from this other table, and join it with the third table, make up a virtual table, right? And then provide that as the input into an actual table. It's almost like a view, right? But now I'm creating an actual table, right? In a view, I'm making a virtual table, meaning after the query, the data goes away, right? Over here, I'm not, right? I'm creating like a view, but it's a permanent view. The data now has been stored into a database, and it's a copy of a whole bunch of tables, right? So I am creating redundancy. Right? Data that I made a lot of effort to split up, right, and normalized. I am now denormalizing. See that? I'm making a copy, and the data already exists in the database, right? And I can generate anytime I want. Why would I copy it? Yes. And this technique actually works out. Like for instance, to implement what sometimes referred to as materialized views. So materialized views is a technique that identifies the importance of views. Right? The importance of views is that I can create a denormalized representation of the data without creating redundancy. Yes, right, because it doesn't really exist. Right? I'm just reading data and I'm generating it and whatnot. Yes. The problem with views is that they could be expensive, right? It means that I am joining and joining and joining. I'm generating the results, and I'm just throwing it away, right? Right. So if I need to use that information more than once, and I create the view and I create the view, the query runs again. Yes. Right. And I incur into this join cost. every single time I'm using the view. So an intermediate step that I could do is that, hey, what if I can run this view? I make a actual table, right? It gets stored in the database, right? And then next time I want to use this view, well, I don't have to run the select statement again, right? The data is already there. So I have created redundancy on purpose, okay? With the intent of improving performance, right? Of saying, okay, well, and only if you know what you're doing, you might want to do this, right? And they have a very well known set of techniques, right? And it has its own name, so you know what you're doing. This is a materialized view. Meaning don't treat it as if it were an actual table. Treat it as a view, knowing that it's more than a view. Now it's a real table, and it should not be treated as the actual data, right? It's only for performance purposes. Yes, and sometimes it's referred to as we always say that redundancy is bad, but this would be a good redundancy, right? It's a redundancy that you know of, you know its risks, right? You know that this is not the real data; it's only for performance purposes, right? And as long as you know what you're doing, then materialized views are okay. And this is how you would create it, right? At least this would be the beginnings of how do you update it. Yes, you run it, you populate it once, and then you can use it. Another problem with materialized views is that in a view, if the underlying data is updated, then the view would also be updated, right? Because it runs every single time, right? If new records were inserted or fields were updated, if you run the view, those changes would be represented in the latest run of the view. Make sense? Not in a materialized view, right? Because you've kind of made it a cache. You've made a copy, right? And any changes to the underlying data that were used to create the materialized view would not be represented in that view. Make sense? So you've kind of traded with performance for stale, having data that is stale. You're working with the risk that the data that you're working with is not the very latest one. Make sense? So again, as long as the engineers understand the cost benefit of performance, but risking working with stale data, then that's fine, right? Usually it involves also, when the way to fit obviously is if you know the data is stale, well, you just rerun this, right? You just regenerate the materialized view. Yes. Again, incurring in that cost of having to recreate the data. Yes. Again, there's a lot of considerations that we'll talk about them later on when we talk about performance. And this is one of the techniques of creating materialized views for performance purposes. Anyway, so here's an example. We're creating a brand new table, right? Where you create a table of alumni, right? And that alumni, if you remember, we played around with it early on, maybe last week, and that we were calculating that you were an alumni if your graduating year was in the past, right? Or if it was 0 or negative, then you were not still alumni. Well, we could calculate anytime we want that, right? We can just calculate it, we can make it a view, or we can actually create an alumni table, right? And so here's an alumni table, and so here's our select statement that is going out to the students and the departments, finding out the graduation year, and if it fell in the past, right, then you were an alumni. And now we're inserting all that into this alumni table and making a permanent table with all the data of the alumni. Now, the alumni probably is okay. It's safe. It's not like you were an alumni and then you were not an alumni, right? It would be it would be pretty safe that this would not be stale, right? That somehow you became an alumni and all of a sudden you're not, right? Perhaps the list would be stale in that there were more alumni that were graduating, and I kind of forgot to update the alumni table. Yes, so obviously your application would have to make sure that you would update this over time, right? At least once every semester, right? Depending on graduating records. Yes, but this is how we get started, right? On the first go around of the alumni table. So yeah, so when you do the insert into a table, right? When you do an insert into the target table, you have to make sure that the fields that you're inserting into, right, matches the target table, right? That the fields match, B matches B, C matches C, right? And also the data types match, obviously, right? And that's relevant because this select statement, right, could be joining 3, 4, 5 different tables, each table with their own names, yes, with their own data types. And as you aggregate all this data, you have to make sure that you transform the names, right? You concatenate and make sure that all the data types are correct, right? And that everything matches, right? That B is B, C is C, and D is D with the correct data type. So here's a simple example, right, where the underlying select statement is joining tables X and Y, right, which have fields that are called, E, F, G, H, right? But the target table is expecting, A, B, C, and D, right? So we have to make sure that we, rename the fields, right? Make sure that the data types are correct, that the data type of E is the same data type of A, the data type of F is the same data type as B, and so on and so forth, right? We have to make sure that those things match, right? You can also, instead of doing an entire table, you can insert just a single record, right? Like for instance, as an alumni, right, I might calculate a first pass of what the alumni table might be, but as people graduate, I can insert more folks, right, into the same table. I can do one record at a time. In this case, the select statement, right, is retrieving a single record by primary key, and then I'm inserting that one record into the target table, right? You can also kind of merge together the create statement with the insert statement, right? If you're gonna do this insert into a create table, right? You would first have to create the table and then do the insert into select, or you can merge that into one single statement, right? So you can do like create table, and right there when you're creating it, right, instead of giving it the all the data types and all the fields and primary keys and who's a varchar and who's a date and who's whatever, right? Well, you can automate that from doing a select with some source tables that you're going to, perhaps multiple tables that you're going to join, and this select statement comes back with a virtual table, yes, and that virtual table can be the input into the create statement, right? So the create statement can look at the fields that come back from this query. Says, oh, field 1 is a varchar, and field 2 is an integer, and field 3 is a date, right? And they're called A, B, C, and D, right? So it will create the table, right, based on the resulting query. Pretty cool, yes? Okay. Right, let's take a look at updates. Right, so yeah, so up to this point we've been doing inserts, right? So that's how we can introduce data into the database, right? And either copy or insert individual records. We can also do updates. Once the data is there, right, we can decide to modify the data, right, or remove data that is already there, right, using the commands update and delete. So update, like the name suggests, allows you to update individual records. Oops, sorry. Delete, like the name suggests, allows you to remove data that is already there. Okay, so for instance, you can say the syntax is something like delete from the table, right, or delete star from the table, right? And you can now if you don't specify criteria, right, because there's an optional where clause, right? Presumably this is the one you would use, right? Delete so and so records that meet a particular criteria. Yes, if you leave out the criteria, it'll blow away the entire table. they'll just go, okay, oh, you meant all the records, they're gone, poof, right? Most databases will have a default warning and it says, really, is this what you want? You want to remove all the records? Probably that's not what you want, right? So MySQL does have that flag turned on to warn you, right? And we'll throw an exception saying, wait a minute, you're going to blow away the entire table. Maybe that's not what you want. Maybe what you meant is delete from the table where certain conditions are true, right? For it'll iterate over all the records, finding which record meet your criteria, right? And they'll just remove those from the table. Okay. Yes.
So when we are doing queries like that, is there a way we can have like some buffer, like a rollback or something? Where
If you put it in a transaction, yes. Yeah. But up to this point, the default behavior is that it's a self-committing transaction. So every command is its own transaction and it commits immediately. Yeah. So, but you can explicitly start a transaction and then everything you do in that transaction until you commit can always be rolled back. We'll talk about transactions a little later. Yeah. Yeah, but by default, everything's auto-committed. Yeah, so if you run it, it's done. It's permanent. Yeah, so cool. And so here we have a table with persons, and we are removing the record whose last name and first name, it's Edward Norton. So poof, it's gone, right? No record of Edward Norton in this table. Or you can have a where clause where you can determine using some criteria, right, where you can calculate which records you want to remove, right? In this case, okay, well, give me only the ones whose section IDs, if there's an enrollment, or if folks are, or for instance, if you had enrollment records, right, that didn't have a selection ID, I would just want to remove all those, right? Just remove all the enrollments where there's no section ID, right? Just blowing them away. So I could use the not in, right? So if I find the sections that are not in enrollment, just blow them away, right? I might have opened up a whole bunch of sections, nobody enrolled in those sections, right? And so why keep those records open, right? If no one enrolled in them, I could just blow them away. So it could be as complex as you want to identify which records you want, right? Update, as I mentioned earlier, right, allows you to modify an existing record. You can identify the record with a predicate, saying, only the records whose column are meet this criteria. And once you identify those columns, those records, you can say, okay, well, I want to modify the value of the first field, the new value, then the second field, and so on and so forth, right? You can modify each one. The same validation applies, right? That if the correct data type needs to match, right? If it's a varchar, you need a varchar. If it's a number, and so on and so forth, right? Or that if something is not null, you cannot set it to null, right? So the same validations apply, just like inserts. Okay. The also all the other validations apply that we mentioned earlier, right? All the constraints that we mentioned earlier about your referential integrity, right? Or any checks that you might do, or any cascades that you might have that we talked about earlier, those also apply, right? So if you try to delete a record that has a primary key that a whole bunch of other folks are referencing through their foreign keys, yes, that would the database would stop you, right? Because you have a whole bunch of other records that are referencing you. You cannot remove this. So all those still apply, right? Same thing, if you're trying to update a primary key that a whole bunch of foreign keys are referencing, the database would stop you, right? So all those still apply, right? So here we are updating and we're setting the address that Norton, we didn't have the address at first, but now we're going to go back in and identify that particular record and set the address and the city. Yeah, so yeah, be careful, just like in the delete, right? If you don't have the where clause in the delete, it could blow away all your records, right? And same thing for the updates, right? If you don't have a where, right, it's just gonna go through all your records and it will make the values the same for all the records. right? If you don't specify exactly which record you're talking about. Okay. So yeah, an update example, right? I'm identifying some folks that were in the math department, and you know, we closed the math department, and now everybody is in the computer science department, right? So we're changing all their majors, and unfortunately now they're going to take an additional year to graduate, right? So we changed their graduation year to the next one, right? Okay. All right. Let's see. Yeah. So let's present the assignment for this week. Okay. Yeah. So the assignment for this week will be to play around with inserts and updates and modifying data, right? We're going to exercise the techniques of modifying and inserting the database. Okay, we're going to be playing around with the same exact database we've been using all semester, right? The same user and replies and blogs and ratings and posts, right? You'll be asked to import the database. This is the same database you imported for the previous assignment. So if you have already imported from the previous assignment, you don't have to re-import it, okay? Unless you think that you might have broken it from the previous assignment, then you can just blow away that and just re-import it again, right? But if you think it's still good, you can just use whatever you had from the previous assignment, okay? So we're going to play around with the multiple versions of the insert, right? First, one of the using specific columns of inserting into column 1, 2, and 3 and the values, right? It's kind of giving you a little bit of review on using these commands, and most of them have ask you to copy and paste this code and run it, and it'll be part of your deliverable, right? Where you're going to look at the current data, right? Selecting a set of users, right? And then you're going to insert into the users, right? In this case, you're going to insert, Edward Scissorhands and Frank Herbert. Dune is coming out October 21st. Go watch it. And so we insert Frank Herbert and Edward Scissorhands, and then we do a select statement to see the users again to see if the insert worked, right? And then we ask you to do it on your own, right? Do an insert on your own, right? So insert a new blog. Let's see, into the SQL screen. Create two. Okay, yeah, create 2 new blogs. So you're going to insert into the blogs table on your own, right? Whose blog name is the Udangir astronaut and NASA spaceflight, right? So you'll create a couple insert. So we ask you to do the same thing. First do a SQL to see what's there, right? Do the insert and do another SQL again, a select statement. So to see that first you didn't have these 2 blogs. Now you've inserted, and now you can see that the blogs are there. Okay. So the TAs, what they're going to do is that they're going to import the database, right? And then they're going to run your script, right? And so they're going to see that, yep, you only have 2 records, and now you have 4, right? So they're going to validate that indeed the inserts actually worked. Okay. Starting from the base database. Okay. All right. So then you're going to practice using the insert statement without the columns, right? And just to confirm that you can insert, with providing just the names of the values without the names of the columns. I'm going to play with that using that syntax. And then we ask you to use that syntax to insert a couple of blogs without the column names, right? So you insert E for electric and space eccentric into the blog, and then I believe we ask you to do the same thing for the posts, right? You're going to insert a couple of records in the posts into the post. Okay. Then we ask you to play around with copying where you insert into a table, right? So basically, you're going to copy a couple of records and you're going to insert them into an existing table. So for instance, we create a brand new table called the unliked posts, right? So remember, we have the post. The post has I think one field that says likes, another field that says rating or stars or something like that, right? And so we're going to create a copy and where we're going to keep track of all the posts that were unliked, right? So basically, it's going to be a copy of the original table, right? But only the ones that were unliked. So we're going to filter out. So we're going to create a brand new table. We're going to drop it first, and then we have an insert under here, which is going to filter out only the posts that whose rating is 0. Right. So we're identifying those posts and then inserting them into the unliked posts. Okay. Then you're going to do something similar. The liked posts, and you're going to populate it yourself. Then you're going to play around with the updates and deleting records. Okay. And anyway, so that's the assignment for this week. All right, that's all I had for you today. Any questions? Questions? All right, awesome. Is it okay if I take a picture, a selfie for my mom? Hello. It's her birthday, so thank you. All right, thank you, everyone. That's all I had.